Alright guys, welcome back. We're going to be solving another question from the second chapter of engineering mechanics by Meriam. And we have a commercial airliner with 4 jet engines, each producing 90 kilonewtons of forward thrust, which is in a steady level cruise. When engine number 3 suddenly fails, we need to determine and locate the resultant of these 3 remaining engine thrust vectors. We can treat that as two-dimensional problem. So we can see that we have 3 forces in here, and for finding the resultant, pretty easy. We just have to find sum of all forces in here. Let's just show our x and y. So that's going to give us our resultant, which is basically, if you look at it, we say all the forces are horizontal and they are going along the negative x-axis. So I'm just going to put negative 90, I'll just multiply it by 3, so negative 270. That's going to be our, and the unit is kilonewtons. It's going to be our resultant, and the question is telling us to replace it with this r, so we have to find the distance or locate this force in order to make the same moment. So let's figure out the moment first of all. So we're just going to call the center of this point maybe G, and we're going to find a moment about G and counterclockwise positive as always, which is our sign convention. So we can see that the top one and bottom one of them is going to make a moment in this direction, the other one in the opposite direction, same amount. We have same forces, same distance. So the moment of these two forces are going to cancel each other out about point G again. So we're just gonna go with the moment of this 90 kilonewton applying at this point 2. We can see the moment is clockwise, so negative 90 times the distance, vertical distance from G to the line of action, which is 12. So that's going to be the moment of the G, and we need to replace this resultant that we found that has a magnitude of 270 kilonewton. But we need to find the distance in here in order to make the same moment, and obviously that force has to be somewhere around here in order to make a clockwise moment. So if we are looking for this distance d, so the moment of this one is also counterclockwise, so negative for that, and basically our d is 90 times 12 divided by 270. We can cancel these. We're going to have 12 divided by 3, which is 4 meters. And yeah, if we want to show our final answer, if this is the airplane and this is the point G, we can replace all those 3 forces with one single force that has a magnitude of 270 kilonewton and is in distance of 4 meter. And these are the things. And yeah, I hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.